Hi guys, welcome to another Learn Electronics Repair video. I have this to repair today. This is a transmodulator. Yeah, even in Spanish you can probably read that. Transmodulator, yeah. So what this does, you feed in a satellite signal, yeah, from two dishes, or in this case one just feeds into the next. So from one dish, and then in here is two satellite receivers. But instead of receiving one channel, it will receive all of the channels, digital channels, on that transponder. There could be 4 channels, 8, 10. And then you can select channels from each transponder, usually 4, 5, 6 channels. It has a limit of how many channels it can select from the transponder. And it converts it into a terrestrial digital signal, which comes out here. So basically, and this is from a hotel. They have a load of satellite dishes up on the roof pointing at different satellites for different nationalities, and they all feed into a whole row of these units. And then we daisy chain the RF signal, so coming from the antenna for the terrestrial TV, the Spanish TV, comes in and out goes to the next transmodulator, the next, and so on. And this hotel has about 105 rooms, actually apartments. It's an apartment hotel, and they have quite a few of these, and they have about 75 TV channels in total. So I have the contract to maintain this. I've been doing it for a few years now, probably 4 years. And this equipment is quite old and gradually it fails. And this one is faulty. So from what I can see, I was out on site yesterday. It was doing 2 things. One, that it was not powering up, so no lights are lighting up on it. Yeah, it doesn't light up. And the second one is that the signal coming from the satellite dish here, the out went to another one of these same transmodulators, dual input, if you like, again, dual transponder, and that one wasn't receiving a satellite signal, so the light was on red for status and a lot of channels were blank. So I took this one out and I effectively took the satellite dish cable coming in and used a coupler and connected it direct to the out to daisy chain to the next one, and that one then started working. So I now have quite a lot of the channels back on, but this one is dead, and obviously the channels that it handles are not working. These transmodulators, 2 of them actually handling German TV, plus a third one, so there's 3 of these that handle German TV. And then we have similar for Italian TV. We have English, we have Scandinavian, okay? So that's what we basically have in the hotel. And a big dish farm, I think you can call it, on the top of this roof, from small dishes, which is this one, to huge dishes, okay? So this thing is A, expensive to replace, and B, a bit of a pain in the ass as well, because these were already in before I set the system up. I've replaced a 4-channel one, like a double-sized one of these, a few years ago with 2 units. But I then had to work out all the channels that were supposed to be coming out of the unit and configure the new one to do it basically. And I added quite a few channels at the same time as well. So not only do I have to replace this, but I have to configure it. And this particular brand now are no longer available, so it just all becomes more and more hassle. You basically connect a laptop to the Ethernet here, and this is how you program it. So it effectively has a web page internal, like a web server, a HTML page, and from that page you configure it. It will be much easier and much cheaper if I can actually fix this one. Yeah, because to replace one of these and configure it, you know, you're talking up to around €1,000. Yeah, it's not cheap to change and configure these. Obviously the hotel would like to save some money, and to be quite honest, I can make a decent profit from this if I repair it, because it's worth a lot of money to them. So let's try it. Okay, let's now you know what this actually is if you've not seen one before. Let's try it. This is a modification I added on all of them a few years ago. You can see the usual corrosion is set in, being next to the ocean, but the fan is spinning freely. And I actually used an ATX power supply, which is just not on the computer, it's just set to come on when you power it up, and I have a load of these all connected to it, so I have fans on each one. Prior to that, it had a habit of falling over when it got hot up there, and it gets hot up there, believe me. Yesterday here was probably 27 degrees or something in the early afternoon when I was there, and that room was probably like 37 inside with all the equipment running. Yeah. So let's take this off first, and let's have a look at the unit. Okay, just heavy dust. This is, it's not really corrosion. This is effectively Saharan sand. Let's power it up. So quite simple, power in the bottom, just power on, and this should effectively boot up. So the Ethernet lights, although they don't normally have cables attached, once they configured, they will come on, and this will come on, and it's not doing anything. Yeah, not doing anything. So let's see if we can fix it. I've actually worked on these before. I think they've all been recapped some time ago, but that was probably 2 or 3 years, probably 3 years ago. And I'm not sure if I actually recapped all of them. And to be quite honest, the capacitors all looked okay and tested okay anyway. It was just a general maintenance job. But actually, you know what, I think actually I removed them all, tested the capacitors, and probably replaced some of them, or yeah. So that's been done. Although I did replace them with capacitors that were pulls, but I did test them all for ESR and for capacitance, and none of the ones I removed actually measured bad anyway, to be true. I think, as I recall now, I did that before I fitted the cooling fans, because they kept falling over. Yeah, that's what it was. And then afterwards, it didn't fix the problem, so I fitted the ventilation, and that helped quite a lot. So we have inside here, as you can see, a power supply. Nothing really strange about this. It's a power supply. I'm going to unplug the power lead. And now let's see if we can actually get to it. Now, because it didn't power up at all, this may have some charge in it, in the main capacitor, so I need to be a little bit careful. I can see, and maybe you can see, there's a power lead coming down here. This is coming from the mains in, and then there's another power lead here which goes into the unit itself. That's the low voltage side. Further down inside there is the large main capacitor, so I need to keep my fingers away from that at the moment so I see if there's any charge in it. There won't be any voltage on this because it's connected via the bridge rectifier from that capacitor. The bridge rectifier is just there, and if the rectifier had a short in it so it could connect back here, it would have blown the fuse anyway, so that's not a problem. So we can remove that. Now we can see inside it. Now you can see inside it. It's full of dust and dirt. I hope it doesn't. I can't see how any water's got in there given the location of it at the hotel. But it's possible the power supply is working, and the problem is actually with the circuit in itself, you know, the transmodulator. It may be that is the problem. Just want to try and get this off here. Okay, I think I can actually just get my screwdriver in between. Yeah, it's coming off now. It's coming now. Not particularly easy, but it is coming. Okay, little bit of persuasion and the power supply is out. First things first, is the fuse intact, and also is there any charge in it. Ohms range. Fuse is good. The fuse is good. Is there any voltage in it? Hold this in. Volts range. I can measure this across the pins of the bridge rectifier if I can get to them. So plus is here. Can I get to the minus? Yeah. There's half a volt in, so that tells me there was some voltage going into it. Okay, we can now dismantle this. Okay, let's double check. So the main capacitor is across here. Is there any voltage in it? There shouldn't be. Yeah, wrong way round. 0.3 of a volt. So there's no high voltages in this, so it's quite safe to work on. Why isn't it working? Don't see any visible problems. Let's zoom down and let's have a good look. Well, we can see that this power supply has several outputs, so it looks like it's got 5 volts. It has plus 15 volts and then a minus V, which could be a minus 15, I'm guessing. The two will be plus and minus. It has ground, so that's what we have. So we have a plus 5 and a plus and minus supply, which might be 15, if that's what that's actually saying, just side of that link. No, that's saying J5, so that's not a 15 volt. So it's saying 5 volts and there's a plus and minus something or other. Yeah. The capacitors look okay, but I have actually changed these on this at some point or other. I think, I'm not sure if I did all of them. Let's have a look. Well, if I changed them on this, I made a good job of cleaning the soldering up, so maybe I didn't do this one. Maybe this one wasn't acting up at the time. On the high voltage side then, we have a controller, which is here. No, it's actually an op-amp chip, TL, I think it's an op-amp chip. TL3842P. I'll have to double check that. I think it's an op-amp. Couple of opto isolators. Probably the voltage reference, this one, TL431. Let's have a look. And focus the camera, we can see. Yeah, voltage reference TL431, I'm pretty sure. We'll just use a magnifier. Yeah, it's an equivalent, AZ431. So that's the voltage reference. This is a MOSFET, I would say. It has 3 pins on, so it's not some sort of integrated controller. It's a MOSFET that'll be driven by this chip. So maybe this isn't an op amp. We need to find the data sheet for this one. TL384. Is that 2P or ZP? It's a 2. Let's find the data sheet for this chip, and then we'll probably have a good idea how this works. So this, in fact, is actually a pulse width modulator controller. It's not an op amp, so that's obviously driving the power supply. We have a data sheet here. They come in different pin outs. Ours is the 8 pin. Doesn't give us much information. There's a block diagram here. So it has an internal reference voltage. That's normal for these type of things. Timing components, resistor and capacitor, CT and RT. That's the sets the frequency of the oscillator. It has a feedback. This is the voltage sense, how it regulates the output voltage. It has a current sense. So those are the main things. Is there a typical application? Not exactly. Yeah, this is a laboratory test fixture. It's not exactly a application, although it does show how to make a tester for these, which is handy. Okay, I'm sure we can figure it out anyway. That's what we have. So I think the first way to test this is a couple of things. We'll check for short circuits on the outputs, but I doubt there will be any, because I thought it would have blown the fuse. But having said that, the current sense might have stopped it from doing that. And then we'll have a look to see if our chip has any power on pin 7. We can do that with the voltmeter, and while we're at it, let's see if it has a reference on pin 8, because that's often a good indication at least the chip is partially working if it has the correct reference voltage, which I think is actually 5 volts. We just saw from this, yes, 5 volt reference. So let's have a look at that. So ohms range will connect from ground, which is clearly marked here. This is ground, and we'll check all the outputs for short. So this is the 5 volts. It has a resistance on it. Maybe a bit lower than I expected, but it's not as short. I mean, 50 ohms at 5 volts is about 100 milliamps. That has a resistance into the hundreds of ohms and climbing up. And that one just reads open. The output on the 5 is a little bit lower resistance than I expected, I will say. Where's that connected to? Let's have a look. So it goes back into this circuit basically. It's quite possible there's a resistor that puts a load on this, although I'm a bit surprised, but there could be. What I will do while we're here is just check for shorts on the diodes on the output. See if they're okay. So we'll go to diode range. And we have some diodes here, it's like probably double diodes. Yeah. They're reading quite low. And the output pins are probably connected together anyway, because it's like a double diode. That's reading lower than I would have thought. And this one is reading higher. Is this one for the negative voltage supply? No, it gives a bleep like a diode junction. Let's go this way. And that way. Go on this one. Let's go the other way on this one. Is that low resistance? Let's go back to resistance range. Have a look. This is like 50 ohms, I can see. I think what I'll do is I'll take these 2 diodes out and just test them out of circuit. They're a little bit unusual, the readings, not quite what I expected, so let's take those out. There's a resistor down here. Is that the... I'm interested to see if that's what's actually reading the 50 ohms, which looks like it's here. Yeah, it was a good guess, weren't it? So I think it's likely this has just got a 50 ohm load across it, which is this resistor. Probably something to do with stabilisation, actually, although it's just wasting 100 milliamps. So we can take these diodes out and test them. In fact, you know, actually I might just take this resistor out and then test them. Let's have a look. Let's take the resistor out first, just out of interest, so we can see how it affects the readings on the diodes and if they then read as we expected. If you can hear the noise in the background, that is the vacuum desoldering tool. The reason I looked at this resistor, by the way, to see if that's where the 50 ohms is because it's quite a large resistor. And if you think about it, if we have something connected across the 5 volts rail that's drawing 100 milliamps, that's dissipating at least half a watt. This seems to be a 3 watt resistor by the looks of it, so that's why I looked at that, to see if that's where the low resistance was. There were some other quite large resistors here, but you can see this is the high voltage side of the circuit. So this gap, which runs around here, basically isolates the low voltage from the high voltage. This has hot ground, this has safety ground, and it's isolated by the transformer windings and by the opto isolators. Now we've chatted about that, this soldering iron will have warmed up, and also the desoldering iron will have warmed up. So let's have a look. This is where I can see the resistor. Okay. A bit of leaded solder on this. But the way you go about this sort of work, guys, it's kind of up to you. You know, if you want to remove the diodes, if you want to remove the resistor. That sounds nice and clean. I'll take this out. And I'm hoping without this in, the diodes will read on I would expect in circuit, and the low resistance across the 5 volts will have disappeared. Some ways that I need to run the solder sucker for longer to stop it clogging up, so we'll try it. So there's our resistor, which now should come out quite easily, if I just find the right tool to do it with. Right, okay, come out. There. So that's the resistor, 51 ohms, pretty much as I expected. So let's have a look now what we have. So across the 5 volt rail, ground 5 volts. That's not the 5 volts, sorry. It's actually this one. So now reads much higher, yeah, across the 5 volts. And we can probably now read the diodes in circuit. Okay, diode mode. Well, that sort of reads like a diode junction. I mean, it bleeps. What's it reading the other way? But it reads it both ways, so I'm still not totally happy about that one. This one no longer has the low reading, it's just climbing up. And the other way actually reads 0. No, reads 578. Huh. 137. That's like a Schottky diode now. Yeah, 137, 137. And the other way is just going to a high resistance, basically. So that diode to me looks okay. And the other one, Yeah, must it read the other way around? I'm still not sure about S1, to be honest. Why it's reading both ways. It's not a short circuit diode. Let's take it out and let's have a look. At least this way we can eliminate the possibility it's causing a problem. Don't worry about the fact it's bridged over. I'll soon sort that out with the desoldering gun. Okay, some solder on. That's clear. Okay, let's go. Give it a few seconds to just melt. Okay, it cleared it. I'm just going to clear the tool. Yeah, it's a little bit clogged. It was sucking, but it's a little bit clogged. Okay. Yeah. Better. I think I'll clean it out. I cleaned that out recently. I don't think that is actually clogged up with solder. But just something just as that goes in, which is basically to the end of the tube, here is blocking up. I'll get this all the way down now. Okay. I can normally tell by the sound the pump makes, and I'm sure you guys listening to that have also figured that out by now, yeah. So let's just get this off here and just check it. I think this is okay. I just want to read the resistances around here. Okay. See how much easier those sort of tools make these jobs, yeah? What we got? Well, you see we've got a double diode. You can see what it is. Yeah, let's check it. So, this should conduct, I would think. Yeah, 400. 400. And the other way shouldn't conduct. In fact, it doesn't conduct. Okay, I thought that was probably okay. What we're seeing in here, so these two ends will probably connect together. To the I'm not totally sure why I'm seeing that. Okay. There's another power resistor down here, and I'm wondering if that's what's actually doing it, like the other one was, effectively like a resistance across the output of here. And it's quite old. I suspect that's doing it, I would think. Okay, so we'll put this back in. We'll shall we take this resistor out just to be sure? Yeah, why not while we're here? It's not difficult, is it? Let's do it. And then you'll see what I expected to see, yeah? I expected to see an open circuit basically across there. Just take this out. We'll do this for educational purposes, guys. I'm confident there's nothing wrong with the resistor. I'm confident that that's what's causing that reading that I'm seeing, which I shouldn't be. And I'll show you why I shouldn't as well. Let me just show you. it out. So this one is a 100 ohm resistor, 10. I assume that's a brown. It's either an 100 or it's a 10. We'll soon find out. Let's have a look. Makes sense that it's an 100 ohm resistor. Let's have a look. Could be a 10. There's a 10 ohm resistor. Okay. Now let's have a look across where this diode is. I'm expecting, yeah, now it's climbing up, yeah. The fact I'm seeing 315 ohms tells me somewhere there's still a resistance across that rail, but it's about 300 ohms. I mean, there's more of these resistors around in here, to be quite honest. Does that one read 300? Yeah, it does, doesn't it? It does. Okay, let me just draw a bit of on paper so you can see why I'm doing what I'm doing. So what we have basically here is we have these double diodes. And they're connected like this. Okay, and in our case I can see that these two ends are just connected in parallel, so they're just being used like two, and these are coming from a winding on the transformer which goes to safety ground. Okay, and then on this side we have, you would expect, capacitor to ground. Okay, we have a camera going a little bit out of focus, try that. We'll have quite possibly an inductor in here, capacitor going to ground, yeah, and then this is your output voltage. So when I measured across the diode this way, I should see the voltage drop across the diode. Our diode is a Schottky diode, so the first one read something like 0.16 volts, which is normal for a Schottky. A non-Schottky diode would read about 0.55 or something like that. But if you read that way across, it should read nothing. It should be open, and I wasn't seeing that. Okay. If you take the diode out and you measure from here to here, which is what I was doing, okay. So once the diode's out, you would expect to read open circuit because the diode's not there. And anyway, in resistance range, you can't actually turn the diode on. If you're in resistance range, you need to use diode mode to do that. So that would be open, and the reason it would be open is because once these capacitors have charged, okay, you may see the charging of it, so you might see the reading while they charge. But that should then read open because there's no path to ground for DC down here or down here. And the output of the power supply is not connected to anything. We don't have anything on the output. There's no load. Okay, so that's what you would expect to see. What I was seeing initially was quite a low reading, or reading both ways. And the reason I was seeing that is because on our circuit, we have a resistor here to ground, and it's 10 ohms. Yeah. So with that resistor there, and remember that this transformer coil, this is the primary, secondary, this has a low resistance. So when I measure from here to here now, although the diode's not there, I'm measuring through this resistor, through ground, back through the coil and back to there. So I get a low reading. So I then removed that resistor. Yeah, and I'm still reading about 300 or something like that. And when I look further along, I can see another resistor here, another power resistor. Yeah. And that one, although I haven't checked it, the resistance I see from here to here is the same as the resistance I measure across the resistor. Yeah, I measured across that resistor and it's reading like 300, and I measured across here and it's reading about 300. I have the same readings. So without looking where that resistor is going, it's obvious one end of it connects to here somewhere, either side of this coil. If the coil exists, the coil is probably there, so it's actually probably on this side of the coil, but it's irrelevant to the meter, because the meter, that is basically 0 ohms through the resistor, through ground, back through the coil, and back to here. So that's what I'm now reading here to here. I'm reading the value of that resistor. I haven't taken it out, but I can see the colours, or maybe you can see the colours. Orange something, which makes it a 33 ohm or a 330 ohm. I think it's actually a 330. So that's orange brown. Yeah, it's down in there. So that's why I was making those measurements, and that's also why I'm happy that all I'm seeing is the value of these resistors, and the resistors are okay. And these resistors are obviously designed to put a permanent load on this power supply. Something to do with regulation, I would think. The bigger resistor I removed was actually on another secondary to the coil. I'll put it down here. Another secondary. 2 more of these diodes, same sort of arrangement, double diode package. Yeah, 2 capacitors, to ground. Looks like we have another inductor coil here, so we'll say there's another inductor. We'll say there's another capacitor, because there's enough capacitors around here for it. 2 there, another one there. Yeah. And we'll say that that other resistor, the bigger one, is actually connected here. And again, when I was reading across the diode, I was reading through that, which is basically 0 ohms. This is, which is a low value resistor, back through ground, back through this, which is 0 ohms to there. And that's why I was reading the low resistances. Okay, so let's put all those back in. Everything seems okay. And let's have a look to see why this isn't working now. Next thing, what's happening around this chip. To measure the voltages on this side, I'm going to reference to ground, which I know is here. But on this side, I need to reference to hot ground, which is the negative end of this large capacitor, or the negative end of the bridge rectifier. And I need to find somewhere where I can easily attach the meter probe onto hot ground, and it may well be that this heatsink is connected to hot ground. So let's have a look. The large capacitor is here, and this is the negative end. Okay, does that actually connect to that heatsink? Yeah, this is very common. This is very common that you'll find that. So this is hot ground. So just bear that in mind, but especially on the high voltage side. This will be on the low voltage side. This will be safety ground. Yeah, in fact, you can even see there's a ground terminal there which goes to the end of this heatsink. That's safety ground. So that effectively, that one, if we look on our meter, is connected to ground on here. Oh, it's not connected anywhere. Okay, doesn't always. So that one is just safety ground. So this is hot ground. Let's have a look to see what voltages we have then. So we'll just select voltage range on the meter, and we'll switch it on. I've just attached one of these basically. I do have another one which solders on rather than clips on, but I couldn't just lay my hands on it, unfortunately, so we'll do it this way. So we'll power on. We powered on. Let's look on the output side first. So do we have any output from our supply? Well, this is ground. This is the V minus. This end is the V plus, as it's called. And we have some voltage coming out of this there. We have 12 volts there, and we have this 5 volts. 5 volts there. So on this V minus, well, nothing really. And it goes to over limit. Yeah. So it looks like actually the power supply might be working. Now all the voltage will go away because of the resistors on the output will drain them away. The only thing I can say for sure is this voltage, whichever this is, this VI minus VI isn't working. Let's just go again. Power on. Ground. 12 volts. 5 volts. Nothing on that one. So it looks like the power supply works, but one of the outputs has nothing on it. I don't know what's supposed to be on it, but I don't see it's in any way controlled by an interface this to switch it on or off. So we need to have a look to see where that V minus goes. I mean, it's possible that on this power supply it's not implemented, that, you know, I mean, I can see, for instance, a component here that isn't fitted, something here that isn't fitted. It may well be that that actually is not connected on this power supply, and it's effectively an option, so a different model with the same PCB would have some extra components here. That seems fairly likely to me, but we'll have a look. I have it unplugged. We can just check there's no charge in the capacitor, but the fact it's actually running, you wouldn't expect it to be. We know where hot ground is, we know where the positive the bridge rectifier is, and we have about 1.7 volts. That's perfectly safe. Let's look. So this is the pin, the V minus, yeah. Where does it go to? Well, it goes down here, and it goes to here. And I don't think it goes anywhere else, so it might go somewhere across here. We can get a good idea if it goes anywhere else. Just go to ohms range and measure from that pin to ground, which is on this one is here. It's open circuit. It goes to here. It's got a good connection on it. Sorry, it goes to here. It goes to here, and this is where there's something missing. Yeah, this diode here, this component. Yeah, so from what I can see, that output is not actually used for anything. Yeah, it goes to these components here, but again they are missing, the two of them. Yeah, so that doesn't actually appear to go anywhere. There's a wire link here. Where does this go to it? I'll just check. I think it actually goes. I can just check if it goes to that wire link, but I don't think it does. So the V minus is here. No, it doesn't go to that wire link. So the V minus isn't used. This power supply is a 5 and 12 volt output, and we have outputs on it, so that suggests we've got a problem with the main unit. Whether that's something I can fix, I don't know, but I can have a look at it to see if there's anything obvious on there. Well, looking in here, I can see straight away these look like two buck regulators. This may also be a buck regulator. This looks like a linear voltage regulator, so we can at least see if there's any power getting into this. The way it's behaving, nothing's lighting up, it's like it has no power. I can also check for shorts as well here on the power connector coming in. So let's do the obvious things. I'll just work out which way round this goes on here. Okay, so the one nearest to me is the 12 volts, then the 5 volts, and then ground is the ones before the end. Okay, so this is ground. Well, there's no short on the 5 volt. There's no shorts on the 12 volts. There's no shorts there. I think this is the ground pin. No, it's not, so they're 5 volts. So those two are both 5 volts. I think they connect together. Yeah, and I think these two are both ground. They both connect together. Yeah. So there's no short circuits on this. If I take this piece off, I can probably get the power supply to attach to this, and then we can check the regulator on here to see if we have some other power rail down. I think now I can actually, yeah, if I just raise this up on something, I can power this up. I don't need to get the PCB out. The other side of the PCB has no components on it, or maybe just a few little capacitors. So there's nothing really there. Again, we know there's no short circuits on the input. There could be short circuits coming from these voltage rails. So let's just clean this worst of the dust and dirt off here. And then let's have a quick look for any shorts on these voltage rails. I'll have to use a bit of ISO, it doesn't want to come off easily on there. In which case it might be easy to take this board out. I think it's just held in by all the screws on here. Sorry, all the nuts on these, so we can undo those. And I think it will then come out with a couple of screws. Yeah, here. Okay, let me get it apart. Now I've dismantled it, I've found in actual fact there is another PCB under here with some more supply rails on. So there are 2 of these, and from what I can see, one is for each. No, I tell a lie, this one has got the satellite signal coming in, out, in, out. This is the satellite receiver, and this one is the RF, the UHF, terrestrial TV if you like, in and out. So this one is the satellite receiver, and this and demodulator, yeah, satellite receiver and demodulator. And then this one is the TV transmitter, if you like, and modulator. So that's what we have inside it. Now I'll just clean all this mess up. So on here then, this is the satellite receiver board, dual tuner. We have some chips. This looks like it might be some sort of power supply. It has capacitors around it, like multi-rail. I'm not sure, but I don't see any buck regulator coils. But I'd certainly look for shorts around the capacitors. This is quite clearly a voltage regulator because although I don't recognise the part number, it has a capacitor on the input and one on the output. So we can certainly check here for short circuits. I'll just check, I think the middle pin may well be ground. Let's have a look. Yeah, it goes to ground. So this is the input, and there's no short, and this will be the output. There's no short. That'll go to this capacitor. That tells me this is a voltage regulator. This will go to this one, yeah. Voltage regulator. And there's no problems there. This one here, I don't know what it's doing. There's an oscillator here, a crystal, 25 megahertz. But we can have a look for shorts around these capacitors. I'm guessing the black stripe is the ground end. Let's have a look. Yeah, so any shorts around here? No. Reads open. No, it reads a resistance. There's no shorts on it though. So whatever these are, I'm assuming because there's capacitors, they are voltage rails. None of them are shorted to ground, so that looks okay basically. We have obviously 2 buck regulators here. We can see the coils. This looks like it's the controller which drives both of them, and we can again look for short circuits. No, there's no shorts there. Same on this one, no short circuits. And then these look like 2 self-contained buck controllers basically. Quite clearly there's a coil on them. Not sure where the output is, but it's going to be on one of these capacitors, that's pretty much for sure. So let's have a look. I'm not sure if I can get to the coil itself, but we can look on these. Is it then ground? Yeah, other end's ground. That end's probably ground. There's no short circuit. All these tantalum capacitors, I think they are, these ones. You wouldn't expect anyone to have shorts across them. So these are good places to just look. Any short circuits, you can think there's something suspicious. Okay, another one of these. One end will be ground anyway. Yeah, here. No shorts there. Again, we can look. This is probably the output, I'm guessing. I'm guessing, but it's probably a good guess. And again, there's some capacitors on here. One end will be ground. I'm sure these will be input and output capacitors. Actually, that end reads resistance. This end will be ground. Well, maybe it isn't, but there's no short circuits. That end's ground. So I don't see any problems around there. This looks like an oscillator. Another crystal. Is that something to do with a real-time clock? Not sure. Looks like 18 something or other. Usually if it's these frequencies like that, there's something to do with clocks. So all those look okay. I mean, we can power it up and test all these have voltages on them. If they have voltages on them and they look reasonable, shall we say, we probably can't do much more with it. This is the TV tuner, the modulator. This looks quite badly corroded here. In actual fact, one end of this capacitor will be ground, which will be this end. Okay. To the metalwork, yeah. So that's a ground point. The other end will be a voltage rail into the kiloohms. And I'm just not sure that capacitor. I think it's okay. I mean, it's hard to say. Could just change it anyway. 470 microfarad, 10 volts. Again, we have some corrosion around here, similar. But this end will be the ground end of it. So it should connect to that one. Well, possibly. I mean, we don't know where they are on the circuit. That doesn't go to ground. I'm not saying it necessarily should. What about this one? That one goes to ground. Okay. Might be some problem here. I think I'll unsolder these two and have a look what's underneath them. Other side, I expect this to be a voltage rail. Are these in parallel? No, they're not in parallel. So they're not on the same voltage rail. Okay. This looks like another regulator to me. Capacitors on the input and output. Yeah, one there. One, is it that one? Not actually that one, but I'm sure there is a capacitor somewhere here on the output. Yeah, that one. So again, we can check for shorts on the regulator. Oh, that reads 0. That's what's the centre tab reading? It might be that this is ground. If this is a negative voltage regulator, it's marked, can't quite read it. If this is a negative voltage regulator, and the reason I'm thinking is because pin 1 is ground, and not the middle pin. The middle pin goes to this capacitor. No, we know one end of this capacitor went to ground. I was on the ground end of the capacitor. So the other end of the capacitor, does one go to the middle pin? Not that one. That one does. So that's the input capacitor. This is the output capacitor. This, I'm certain, is a negative voltage regulator, and that's why there's ground on there. That makes sense to me. That also probably tells me these capacitors are okay. This end should go to ground though. It does, but yeah, it does. I just have a connection on it now. It was just a bit dirty there. See if I just clean it up a little bit. Get the dirt out of the way. You'll probably see it's fine. You know, you see the leg now. Yeah. Still does look a bit corroded though. Well, this appears to be all ground. Yeah. There. There. Yeah. That's okay. We can do the same we did on the other board. We can have a look around these. So we know grounders here. I'll put negative to ground. No short. No shorts on these voltage rails. So one end will be ground. That end. These are the ones on the little regulator. No short there. This end will be ground. Yeah. Same with this one. One end will be ground. That end. No shorts on that one. Just double check. It's not short. Same over here. This end's the ground end. They all follow the same pattern. This end is ground. This end is the output capacitor or input. Yeah. These obviously decoupling capacitors around these chips. Shouldn't expect there to be any short circuits here. No short circuits there. Another capacitor here. This end is ground. This end should not be short. Okay, and the last one over here. This end is ground. So, no short circuits. This looks a bit dodgy. Nothing on the back of that one. So let's change this capacitor here. We'll always get desoldered. I'm not happy with it. And then we'll replace that. And then let's power this up and see what we have on these voltage rails. These things can either be easy to unsolder or a right pain in the butt to unsolder. Let's see which this one wants to be. A bit of flux will help. Both ends of it. Is it going to be easy or is it going to be a right pain in the butt? Let's have a look. So, bit of leaded solder on it. Try to get some heat into it and then just try to tip it backwards basically. Yeah. It's been fairly easy, this one. Once we've done that, we can tip it forwards a bit. We can come in from this side. Same sort of thing. And it should just come off the board, yeah. Back to this side again and this will have it now. So, solder like they are. So that's off. Yeah, we can see, look, it wasn't either that's when I've unsoldered it, but more likely this wasn't good here. Okay. Get a bit of braid and clean that up. It's not very clean, that tab at all. See if I can actually clean that up a little bit. And then we can actually do the same on the board. We can test this with the capacitance meter if I haven't got another one. That's coming off now, whatever it is. It's a bit of track or something stuck to it. Okay. Let's have a look at the PCB. Looks like the bit came off from that side actually, but we can fix it. Okay. Okay. See if our capacitor is any good. And if it is, we can actually see if we can actually, yeah, it's plenty long enough to go over the tracks, that's fine. Let's check this with the capacitance meter. And while we're at it, let's check it with the ESR meter as well. Okay, capacitance meter, 470 microfarads. Let's see what we've got. Okay, well, which end's negative? This end. So what we got? Yeah, 470. Yeah, close enough. Try the ESR meter on it, but I don't think these are that low ESR as such anyway. What we can do is also, if we've got a problem with the tracks here, we can actually fit like a through-hole capacitor. There's plenty of room in here, it's not really a problem. Let's see what the ESR meter thinks of it though. Yeah, doesn't really matter which way around you put it. Just get a connection on it. It's reasonably low. What's it selling here? Good for whatever value. No, it's a bit high actually, saying it's good if less than 200, it's a 470. Let's change that. In fact, it looks a little bit bulged here anyway, doesn't look too happy. I doubt this is enough to cause the problem, but let's change it. Okay, this one is saying good if less than 470. It is a 470, so I'm fairly sure we can use this one in here. We'll just make sure it's actually a 105 degrees, same as the original one was. No, it's an 85 degrees, so shouldn't really use that one either. I continue to search. Okay, so I've found one. It's actually a 25 volt rather than a 10 volt, but it's reading low ESR. Okay, and there's enough space in here to fit it. It really isn't going to be a problem putting that in there. There's more than enough room in the unit. Yeah, more than enough room. Just check it with the capacitance meter as well. This is just a case of using what I have, to be quite honest. Yeah, it's close enough. But in any case, it reads a lot better than the one I've taken out. So this I can just effectively just spread the legs out a little bit, and I can solder it across there. Yeah, then we can just check with the other board in place. And there is enough space to do it. Yeah, there's enough space under there to actually do it. I have the PCB under the microscope. I tried to solder the capacitor and this just effectively came off. This is where it seemed to be all corroded around here. And also this end is not connected to here as I thought it was. This is actually the positive end of the capacitor. So if we look across here to here, we see a resistance. Where the negative end goes, which is here, effectively connects to here. You see these three vias, yeah, all connect to ground. So what I'm going to do is I'm actually going to solder the capacitor from here to ground across that way. It'll hold on better. I have the capacitor here, so I'm actually going to fit it across this way. Okay, in fact I may even just lay it down and bend the legs down. I think that would probably work. Let's see if we can do it. Yeah, I think we can actually do it. So I'll fit the capacitor down here out of the way. That'll give us even more space actually, and the negative to ground. So that's the correct way round. I doubt the other capacitor was actually causing a problem, but anyway, let's change. Well, we'll change it now. We have it off, yeah, rather than putting the original one back on again. Of course, if it does work, I could just decide to basically order some of the other type and replace it with one of those. And there is the capacitor soldered, so I have the positive to where the positive should go. I have a good soldered connection on there now, and negative. I can make sure I have a connection by measuring this end of the capacitor. Of course, if I see a positive voltage there, it's connected to the rail, it should be. Let's take some voltage readings. I've just wedged a bit of kitchen roll in here to dry, just so it doesn't touch against this. I can now power it up. This is just the modulator board, the DVB-T, but that shouldn't be a problem. Let's switch it on and let's see what we can see on it. So we have some power on. First of all, do we have the 12 volts and 5 volts? Yeah, we have 12 volts. We have 5 volts. What do we got on our board? Let's have a look at the capacitor that we've just soldered back in place. So that's this one. That's a 5 volt supply on it. What's on these other things? There's a voltage regulator here by the looks of it. Try and hold this a bit better where you can see. I can still get a reading. Yeah, 5 volts. So voltage regulator here. Well, that's nothing. Oh, this end was ground, I think, on this one. .7. So it appears to be nothing around that one. But it might be something to do with the other board not being fitted if it has to activate that. So on this one. Pretty much nothing. Pretty much nothing. Pretty much nothing there. What about these things? We can look around these capacitors. That's probably as good a place as any. 0.7 of a volt. So this looks like it's being powered from this and it's not being powered up. Okay, 0.1 of a volt. 0.7 of a volt. So this board doesn't seem to have any power as such. Well, apart from the 5 volts, of course. Power is switched off. Let's fit this board. So I'll just stick it into here. Okay, that's in. And then we'll try and just wedge something under here to hold it up away from the other board so it doesn't sit on top of that capacitor. A bit of card. That should do just fine. A bit of card in there. See what voltage we can see on this one now. So again, we'll power it up. Nothing lights up on it. What have we got? So is this a ground? I'm hoping this is a ground. It's a ground. That's 12 volt supply. It's a 12 volt supply. 12 volts. Some of these things. Half a volt. Five volts on that end of it. It's only a piece of half volts on it, nothing really. It's on this. Half a volt, almost nothing, almost nothing. So it's like we have power coming into this, but pretty much nothing's actually running. Yeah, like something needs to activate these things. Let's get a thermal camera and see if that tells us anything. Okay. Well, I don't see anything on here, but it kind of confirms what I thought, that it isn't really running, yeah. That's shiny. That's reflective on the... Is this one here just... Yeah, the one thing I can see that is warm is here. So I'm just going to put the... reach it. 1 moment. Temperature points. Yeah. This regulator here is running a bit warm. Let me zoom down on it a bit and I can show you. There. So that's this little module, and it's definitely 50 odd degrees. That is definitely getting warm, so that has some sort of problem. Yeah, can you see it? 45, 50 degrees. Let me see if I can figure out what it actually is. Yeah, I can't feel any heat on it now. It must go cold as soon as you switch off because there's a large ground plane here. Let's see if we can actually see clearly what it is, but it's something on here. Otherwise, maybe a little bit of isopropyl will tell us, but let's have another look at the thermal camera. So we'll power it up. Okay. Let's get the thing the right way round. That's the problem with this, sometimes holding the screen the correct way. So what's hot? You know what, guys? I'm going to try a little experiment. Okay, guys, I've attached the camera. I can probably show you actually. It's attached to an old microphone, yeah, one of the old desk microphones, the €5 ones that are absolutely rubbish, didn't do the job at all. But you can see it there. I have my screwdriver balanced on to stop it tipping over, but it's working. So it's pointing at this little module. You can see it on the screen quite clearly, focused now. That's the other one. Now let's switch it on and see what happens, okay? Oh, and that happens. So this is where our problem is. And it's in this corner of the module, and I think if you look at this one, there's some capacitors down here. I think it's the capacitor in the corner. You can't see it under the camera, but I'm pretty sure that's what the problem is. Let's go again. Yeah, that is a fault. I'm not sure if the temperature readout on this is the right way up or upside down. No, it's the right way up. Let's go again, yeah. So you can see that is 45 degrees, and it's down in this corner of the thing here, and I'm pointing at it, and that's where the problem is. Switch that off, it will go away. So we have a problem with the capacitor in this corner of this little module. Let's look at that under the microscope. Let's have a closer look at these modules then. So this is the good one, and this is the bad one. You can see this has the corrosion on it, so that's obviously not a good thing. Yeah, this here is where it was, something was getting hot on here. I could do with cleaning all the rest of this crap off it, but there seems to be something burnt there. I'll just see if I can just adjust the focus slightly on it. Okay. Okay, well, it's a matter of getting the actual board in focus and not the top of that thing. The thing is with this, they mounted a different way around, just makes it a little bit awkward to kind of work out. You can see on this one that these two things saying JAJ are over here, and now they're down here. So this one is actually rotated clockwise through 90 degrees off this one. So what we see up the side of here is what we see across the bottom of here, okay? And we see there's a little transistor MOSFET, that looks like a diode. There's two capacitors there. There. So this area here is actually where there's nothing on that one. Little green component just above there. Let me try and clean this up as best I can, and then we can figure out what is around here. As I'm sure you've seen, guys, there's a lot of crap around here. I've tried to clean a lot of it off now, but it's still messy. I think liquid's got into this, to be quite honest. What seems to be getting hot is in this corner. Okay, and it's a transistor. Now, I'll just try and get rid of the rest of the crap I can see down behind this chip here. You see this stuff? I don't even know what that is. That might be off the actual tissue paper, the kitchen roll. I've got rid of the worst of that stuff now. There's more of it on here. Oh, top of the body component came off. That's not good. What is that thing? It's a capacitor. That's not a good thing to happen. Let's have a look. Well, it reads 0.065 across it. What's this one reading? Different, yeah, 0.517. I'd say this capacitor's going to have to go. It's reading different now, but I think we can say that is a bad capacitor. We have one here we can compare with at least. It's reading different again now, yeah, it's changed its mind. If we can figure out what this chip is, I can probably figure out what that is supposed to be. These are not going to be easy to actually unsolder parts from, because the thing's kind of like soldered down on here as well. A bit like a BGA. I think it's going to cause all sorts of problems to try and work on it. What I can see is this. So this is a transistor. And I'll just get the meter where you can see it. Okay. So we can look at this. So this looks like the base collector. That's a transistor junction. There's another one there. Yeah? And if we look at that compared with this one, obviously, as I say, it's rotated 90 degrees. But that reads okay. That reads okay. I'm not sure what this thing is. It's marked DX. It seems to have possibly more than 2 pins on. You can see down there. These are not connected together. That end is connected together. What's this one look like? Yeah, it reads like the other one. More crap on it. I think that's like one end of it. It's hard to see. It looks like, as I say, it looks like that's 4 pins on here. That reads the same. How does it read across this way? So it's like some sort of bridge rectifier or something. It's tiny. It doesn't read anything like that. That end reads the same. That reads like a diode junction. So look at this one again. So we see a similar reading around it. That was connected together. This read like a diode junction. Well, it appears to read the same as the other one. I can say that much. It appears to read the same as the other one. I'm going to have to try and remove this. And then let's see if we can measure this one in circuit. I mean, it's a capacitor, that's all I can say. Let's see what reading we get from it, and then let's try to fit something in there, and then let's see if we still have something getting very hot on here or not. Just a bit more crap around it. Again, there's a bit under here. I mean, it might be once I've removed all this contamination, it might work. That looks like it's a copper track from there to there. It looks like there's a pin here. Yeah, that leads to that. Oh yeah, it's just corrosion in this lot. There's too much of it as well. Yeah, that reads okay. Let's try the capacitance meter. I don't know whether this will give any sort of sensible reading on it, but this one, yeah, is reading about 25. So this way, it's giving a high reading like 150, yeah. 25 in that direction. But as I say, I don't know if we get any sort of sensible reading out of them. What's this one read? Well, it also reads about 25 that way. And about 150 that way. So they actually read about the same. And obviously it needs changing. Let's power it up again and let's see whether we still have the something getting hot and whether it is this transistor. I have the camera about as close as I can get it. It's not full level, but I've managed to focus on this end. So I can see that if I touch it on the board, that is the transistor. There, okay, on the end of my preview. In fact, you can see it. The transistor's there. You can see the three legs of it, yeah? So that's where the transistor is. Now let's power it up and see whether that is what gets hot. Okay, just check everything's all right to power it, yes. Well, I seem to have fixed the problem because it's no longer getting hot. It looks like that corrosion might have been what was in the way of it. Just switched it off again. Let's put the business card back in here just to stop it touching. Obviously once it's all screwed together that won't happen anyway. Let me power it up again and let's see what we have. Okay, that appears to be running now. Oh, and it's lighting up now. I'll show you. I'll put it back together, but it's now lighting up on the front, which means it may well be working. I've put it back together enough so we can actually power it up at least. So we'll connect the power lead into the bottom of it. Okay, and we'll just try it now and see what happens. So we'll switch it on, and you can see this is lighting up now, yeah. The status isn't lit up, but there's nothing connected to it. It might come on red or green in a minute when it's thought about it, or the green lights come on, so we know it's booting up, yeah. This is definitely booting up, and that's without the top on the capacitor at the moment. I think the next step with this is going to be to see if it works, so connect it back to the entire system, and then I'm pretty sure this lights up once all the signals are coming in and it can do something. Okay, so we can say it's powering up now and it's probably working as well. So there we have it. It appears to be working. A few things I'd like to talk about this job. So the first one is this broken capacitor. What would you guys do with it? I mean, I can easily get to it by just taking this cover off. It's on the top. Would you try to seal it in with some sort of potting compound, which I have in mind? Would you try to replace it, given the fact the little circuit board is less than 2 centimeters square and it appears to be fixed to the main circuit board by some sort of BGA method? So bear in mind, especially with hot air, you could actually make things a lot worse for yourself. Or would you have some other idea about it? Regards this sort of repair, this transmodulator, I can easily charge the client 150, 200 euros, I think, probably for this sort of work. I mean, to replace this would cost 1,000 euros plus for the equipment. Then you would need to analyze all the settings, the frequencies and the PIDs, program IDs for the existing channels, and set this up, and then set up a replacement to do the same. If you didn't do that, then you would replace it, get the channels on, and then you would have to go to 105 apartments and rescan the TV in every single apartment, which is going to take time and money. If you do analyze the settings that this was using, and we could do that by probably using the TV and go to the channels which are not working, and hopefully in the settings we might be able to see the info, certainly the frequency and hopefully the program IDs and the other settings that DVB terrestrial uses. That will take a few hours, that will cost money. So as well as the, let's say, €1,000, €1,200 for this, you've probably got another €300 or more in labour, and possibly more than that if you want to go and scan 105 TVs in. Bearing in mind you need access to each apartment and there are guests coming and going, so it's not the easiest thing to do, yeah? Regards the way I fixed this, so the thermal camera. I never had a thermal camera till what? A couple of months ago when I first had a chance to play with one. This one I have as my favourite one, the IFPEHHVB T2S Plus. It's about $350, between $300 and $400. It's that sort of price, yeah, somewhere in that region to buy one. But I would contend that if you can fix things like this using that equipment, you've only got to fix 2 of these and you've paid for it. And once you've paid for it, A, you've got an asset which is worth money that you could sell if you no longer need and get a good price for. And B, you've got an asset that will continue to make you money. In my opinion now, the thermal camera is one of the most useful things in my toolkit. And I'd like to know what you guys think about that. So get into the comments below. A couple of things we can talk about. First one, broken capacitor. What do we do with it? Let us know in the comments below. Yeah. Number 2, thermal camera. Do you consider that to be essential for this sort of work? Really? Do you think it's something that we don't need? Do you have one already? And if you don't have one already, what are your thoughts about buying one now you've seen what I can do with it? Yeah. Comments below. So let's have a good chat, and I will just say I will see you all soon on another Learning Electronics Repair video. Ciao for now, guys.